Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, I've had a lot of emails and forum traffic about problems people having with these EAR834 clone preamp builds. And I've done, I think, 2 different video series on how to build these things, but people are still having problems. And honestly, most of the problems people are having is from like totally changing the layout without understanding the repercussions of what their design changes are doing. And I think possibly some people think that I just kind of willy-nilly laid this out and that you can move stuff all around, just whatever you think is more convenient. You know, I want to put the power switch in the front, or I don't like the RCA jacks here, I'm going to move them somewhere else, or I'm going to put it in a completely different kind of case, and I'm going to move the tube sockets around, and just, yeah guys, you can't do that. And I'm honestly just kind of done with trying to diagnose and figure out why they're having problems with all of their design changes for them. And I'm going to show you how I build these, why they're laid out the way they are, and if you decide that you want to do something totally different or you don't like that design choice, then you guys can figure out the problems or how to solve the problems that you create by doing this a different way. I've built about a dozen of these things so far, just like this. The new ones have the tube sticking up just a little more, but basically this layout, and all of them are reasonably quiet. None of them have what I would call loud hum at listening volume. You know, with the volume like set what you'd be listening to a record is what I call listening volume. From the seated position, you don't hear anything. Now, yeah, if you turn up, you know, you got a 50-watt amp and you got efficient speakers and you crank it all the way up with no music playing and go over and put your ear up to the speaker, yeah, you're going to hear some stuff. And that's just the nature of a tube preamp. So, I'm not saying these are just dead silent, but you know what folks are telling me, they're hearing loud hums in the room that you can hear the hum when the music's playing and stuff. And if you build it like I'm going to show you, it's not going to do any of that stuff. So anyway, probably going to be a 2-part video. Going to do one on building the board or populating the board and some of the little tricks and problems that I run across in doing these. And then the second video is going to be more about the chassis and the layout and why things are done the way they are. I'm also going to put a link in the description to a Morgan Jones book about building amplifiers that explains all this stuff and why it's important to lay things out in a certain fashion. And all of my other amps are done the same way. They're laid out the way they are for a reason. And if you start moving transformers around and, oh, I want to put the power transformer between the output transformers and stuff, yeah, you're on your own. If it's, you know, doesn't sound good or it's got noise or whatever, there's a reason why it does now. Is because you've moved stuff around. So anyway, let's go ahead and do this first segment on populating the board and some of the tricks I've found and things you need to look at when you're populating and getting the parts together to get the board ready to go in the chassis. So let me go over the board and show you a few tricks that I've learned on assembling these things. First of all, don't split the power board off of the preamp board. I've tried building them both ways. There is no difference in the noise having this separated from this board. None. And it just complicates things and creates potential issues with grounding when there's no reason to do it. I mean, I even tried putting like a shield between the two boards with MU metal on it. It made absolutely zero difference in the noise signature. I know people think, well, it's got to make a difference. It just doesn't. Next, these come with a 3005 transistor that's used for the voltage regulation. The board says it's supposed to be a 3009, which is a higher current version. While the 3005 will work, the 3009 will be quieter. So make sure you buy a replacement transistor for that. The Zener diodes and the other diodes that come in even the basic kit seem fine. I found that all the resistors that are on the power board are within spec every time. These resistors seem fine, as do these little 0.22 ohm ones that they come with. Those all measure fine. I do put this one rectifier, I don't know if you can really see, but kind of put it at a little bit of an angle so I've got a gap between these resistors and this, and still leave enough room to slip it in the board. And then this little 100 UF cap that comes with the kit seems fine as well, so I just use it. I do buy these without the capacitors because the caps they come with are too tall and they're also of questionable quality. And so I buy Nikon caps. I think these are another brand because Nikon doesn't make any short enough to fit below. As you can see, the heights of these capacitors sit just below the tops of these 35 millimeter tall standoffs that I'm using on my current builds. And I went with a slightly shorter standoff than I used in the past so that the tops of the tubes stick through just a little bit more and allow you to replace the tubes easily. My early version, which I'm going to show you my early version to point out some of the wiring things, the tubes are recessed a little lower inside the preamp, and it's kind of a pain to replace the tubes or swap them out for tube rolling, so I went with these 35 millimeter ones. While we're talking on the standoffs, one of the things I do is, and this is probably not going to be able to be seen, but the ends of these standoffs are perfectly flat, and the little pad they sit on is smaller than this hex diameter. And so on the end that goes towards the board, I go to my bench grinder and just put a slight bevel around the edge of this standoff so that just the very center is touching on this little pad right here to make sure that at some point it doesn't end up shorting out. It's probably not necessary. I know that's kind of overkill, but this little part right here, that's actually connected to the ground. So if the stand ever shorted out to that little thing, it would be an issue. So make sure you use small diameter standoffs and make sure that you don't have this little pad touching your standoffs, because that will create ground loops, because then each one of these will be a ground path, which is bad. You do not want that. The other thing that I found after building a bunch of these is these resistors have tested good, are right on the money every time, as have these around the perimeter. So I use those because, hey, they're, within spec. These ones in the front are almost always off, and you want to make sure in this 47K one that you're using a precision resistor and it's as close to 47K as possible, because that's the loading on the cartridge. And almost every Phono cartridge is looking for a 47K load. Look up the cartridge that you're planning on using and make sure that it is 47K, and if it's not, this is the resistor that you would adjust to match the loading of the cartridge that you're planning on using. These 330Ks are sometimes in spec and sometimes they're not. They usually are off, a few percent, and so I recommend that you check them all, and if you've got two that match and then two that match, make sure you put them like the matching ones on this channel and then this one and this one should match. And that way you ensure that you get, even left to right channel things going on. These don't have to be like, 1% precision, but if they're within, 5%, just make sure you match them as closely as possible from channel to channel. So one of the coupling caps go here, but I install the coupling caps on the other side of the chassis. So there's a coupling cap here, there's another one here, across there, and then there's another one that goes here. There's one here, here, and there. Those are all mounted on the other side. These resistors in here are a real hit or miss. And I have found that these 2 meg ones are almost always 2.2 megs. And these ones that are supposed to be 2.2K are actually 2K. And they're like that on every one. So those end up getting thrown away. Also, this 750K needs to be as precision as possible because it's part of the RIAA network feedback loop thing, and this should be a high precision. If you have to go through several resistors, I usually order batches of 10 of them and go through and try to find the ones that are closest to 750K, because I feel like that if this is off, it could impact the frequency response or the way the RIAA equalization works. The other thing is these boards come with usually these little ceramic capacitors or otherwise kind of crappy looking capacitors. I go ahead and buy these nice mica capacitors. And it's got a place here for 3 capacitors, so you could add up the capacitance, if you wanted to put a 100 PF and then a 10 PF or something, or try to really dial this in. But I just buy 110 PFs and get the 1% precision ones, and they're usually really close to being right on the money. So one of those goes here, one of those goes here, and I do think that using a mica capacitor instead of a little ceramic capacitor in this position makes a difference in the way these things sound. The other thing I do when I'm building these is the tube sockets. I only solder the pin on here and here, and I leave these unsoldered until I bolt the board into the chassis, then put a tube in, and then seat the tube, and if the top of the tube doesn't sit right in the center of the hole that you put in the chassis, then you can reheat these solder joints and move the tube around, or the tube socket angle around, until you get the tubes pointing through the center of the hole you put in the chassis. In case you got it a little off center, or you've got it a little front and back from where it actually should be, you can have the tube, when it's seated fully in the socket, be centered in the hole so that it looks good and the airflow around it. The other thing I do before I even start working on these boards is I reinforce this joint here between the two halves with a fairly large, probably 18 gauge solid core piece of wire and a big pool of solder to reinforce this so the board doesn't accidentally snap in two while I'm working on it. And then let's look on the other side. I do the same thing here. I reinforce the little joint here, there, and be careful on these. You'd want to just barely put a little solder to fill up those holes to help reinforce it. One mistake I did make on a board was I put too much solder, or I tried to do it on this side, and it ended up bridging between this little connection between the boards and this big ground plane, and it was a dead short, and it fried the choke when I powered it up. So don't make that mistake. Make sure that you don't bridge across there when you reinforce that joint. The other thing to notice on this side, it's got a ground marked here, and then on this end of the board, it's got the ground marked here. Okay? This ground you would use if you separated the boards. Okay? It's another reason I don't like separating the boards, because I think you can end up with a ground loop having this grounded and this grounded separately. You really only want to have the board and the ground plane, which is what I call like these big gold parts that you see on this side of the board. All this gold is the ground. And then on this side of the board, all this space in here, that's all ground. Okay? And so you want to make sure that you've got that grounded, because that helps shield the electronics and the tubes and everything from noise. So another thing I found recently is somebody's making a clone of this clone. I guess these boards are so popular that somebody decided to copy them, and you can tell the clone of the clone boards that this finish isn't a glossy black, it's more of a matte black look. And everything seems the same. I mean, the wiring and the layout and everything seems good. The only problem is on this ground point here, which is the main ground point for the board, they've insulated it with a little ring that's not touching this ground plane. Okay? And you can see like these input negatives are insulated, and that's what they're supposed to be. But this is supposed to be connected to this right here. Now on this side of the board, it's not. And you can see it's kind of got a little recessed thing around this triangle, and that insulates this from this. But on this side of the board, this is supposed to be electrically connected to this, which would be electrically connected to all the rest of the grounding. And if you have one of the boards that has this side electrically isolated, the ground will just be floating, and you won't actually be grounding the board. So if you do have one of those, you need to scrape off some of this black paint and either solder bridge or put a little piece of wire from here to this point so that this ground plane, which is all this area around here, is actually grounded to this main ground point. And you can test it if you have one of these boards by getting a multimeter, and this should be electrically connected to that, and like this should be electrically connected to this through the back side. And I hope that makes sense. So make sure that you check that, because you may have gotten, and I've got them from the same eBay seller, both kinds of boards. And so you're not guaranteed which one you're going to get. And some of these come with these kind of coarse finish ceramic sockets, and then some of them come with the glossy ones. I haven't really seen any difference between the two. I mean, they're probably not the highest quality tube sockets in the world, and if you're going to be doing a ton of tube rolling, you might want to get some Belton that are, made outside of China tube sockets. I found those Electro-Harmonics 7025 tubes sound so good that I don't see any point in tube rolling. But hey, that's up to you. Some people want to try new old stock. I have the RCAs, sound kind of flat to me. The Motorola new old stock sounded pretty good. Almost any 12AX7 is going to have more hiss and noise than the Electro-Harmonics new production 7025 tubes are. Now another thing that I do, and I need to go back over these boards and double check that I've done this, is obviously when I'm soldering these components on, I'm soldering from this side of the board, but then I also flip it over and I make sure that the solder has flowed through on this side of the board too. Now these are through hole connectors, so you don't have to do that, but I feel like if you come back and put a little touch of solder on this side of the board too, you're ensuring that you've got a really good solder joint. And I don't know if you can see, but like this one, I need to come back and add a little touch of solder. In this one, and here's another board that I'm working on that I have come back and resoldered all these, and you can see how those joints have solder blobs on both sides of the board. And make sure you've got a really good connection, because I've had people email me with problems, noise, or one channel not working, and it turned out that they just had a cold solder joint because they were soldering just on one side of the board. And I do think too that when you come back and reflow on this side of the board, or add a little solder, that it's nailed down on one end, when you're initially soldering, neither side is like physically nailed down, and so it might wiggle a little bit while it's cooling off, and that creates a bad solder joint. And when you come back and reflow each one of these, then you know that one side's nailed down, so it physically won't move while the solder's cooling off. And that just helps ensure that you don't have a cold solder joint, or a, I forgot what they call that term, but you can put in the comments below what that is. I can't remember what they call it, when the component moves as it's cooling off and the solder joint looks all kind of brittle and cracked up looking, and it's not shiny. So it's worth taking your time, just going back through and like double checking that all these solder joints are really good to have it work first time you plug it in. So the other little trick that I do is I've learned to put a jumper from this point to that point. And we're not using this 68K resistor. That's for if you decided to put a volume control pot into these pins, which we don't do. But if I put a jumper from here to here, and then from there to there, then it makes this the positive and that's the negative for the output jacks. And so then the two wires are right next to each other instead of being like bridged across this long gap here. And so when I've done that, then the negative for the output jack goes here, positive goes right there. They're right next to each other, and it just makes it easier to connect them up. The other thing on these boards, every one of these in this 220 ohm output impedance setting resistor, they come with a 68K in there, which is what's supposed to go across this point if you were using the volume control. So this resistor also is always wrong. So probably what you're going to have to do when you first get the board is take the resistors out, because some of them will measure wrong if they're in position, but then they'll measure right if you pull them out. So you want to take all the resistors out of the board, and then, or one at a time, take them out, measure them, and put them back in. And then the ones that don't measure right, just throw in a pile and make a list of all the resistors that you need to buy to get the values within spec. And then order those. As you're ordering all these good capacitors, and then ordering this transistor, and I also put a little heat sink on this transistor. It probably doesn't have enough current going through it to warrant it, but it's not going to hurt anything to dissipate the heat off of this with a little heat sink like that. Well, as you can see, that's pretty straightforward. And like I said, it's all about, getting a meter like this, or, at least a decent meter where you can measure the ohms and the capacitances of the various parts, especially the PF capacitors and the resistor that's in the RIAA network. And then those are the ones that need to be fairly precision. The rest of it, just a regular multimeter. This little peak meter is really awesome. It saves me a lot of time. I'll put the link to this in the description too. If you don't have something like this, this is really handy if you're going to be building a bunch of this kind of stuff. Obviously, if you're only doing a one-off, just a regular multimeter will get you where you need to be, and just buy good parts. So anyway, we're going to do round 2, where we're going to go over the chassis layout. Again, this is one of my early versions. Maybe, I'm probably not going to have these other ones done by the time I make that video. But I think I've shown you enough in this board layout where you can build my latest version type with the tube sticking out a little higher. And the only difference is just getting the right capacitors and using those 35mm standoffs. And it's not hugely different. They stick up another 10mm maybe, and it just makes it a little easier. These are kind of hard to grab, the tops of the tubes. So anyway, hope you enjoyed this video. If you did, please subscribe to the channel. Please like the video. Thanks to all you Patreon folks, and also you folks who make donations to my website, and you guys that have been buying my preamps. I'm going to have 2 more for sale soon, so yay. Anyway, until the next video, have a nice day.